In lesson 9.2, we're going to talk about lines of fit. So in 9.1, we talked about scatter plots, which we're still going to do, but we're going to take it one step further and look at lines of fit, which I kind of alluded to in lesson 9.1, but we're actually going to work on writing equations for those lines that we draw in. So let's take a look at some scatter plots, and then we're going to take a look at how we can draw in those lines of fit. So what we're really focusing on today is how can you use data to predict an event? And I told you guys this is exactly why I love stats, because we get to make predictions about the given relationship that we have. So we're going to use what we know, and then we're going to take that one step further, and we're going to start predicting what we think the outcome will be. Let's take a look at this first example. So what I want you to do is pause this video, plot all of those data points. All right, so hopefully your graph looks something like this. I'm guessing yours is probably a little bit better. But I hope you also notice that the slope or the rate of change between any 2 points isn't necessarily the same. So what does that mean? It means that we're not going to have a perfect straight line. So it is indeed a scatter plot like we talked about in lesson 9.1. But part B here says, draw a line that you think best approximates the points. So use a ruler or a straight edge or something so you can draw a straight line. Now, how does a straight line best approximate the points? Your goal is to have the same number of points above and below the line. And you want as many as possible to actually be on your line. Now, if it was a perfect linear relationship, all of the points would be on the line. But it's not, so we're trying to get the best fit or the line of best fit for the data that we have. So go ahead, try to sketch in a straight line that best represents this data. All right, so I did my best. Turns out you can't lay a ruler on top of an iPad without making a bunch of marks, but that's okay. You can see that I crossed through 3 points, and 2 of the points down here are below the line, and about 3 of them are above the line. Now again, I know this isn't perfect, but it gives us the idea, and now we can do C. Our equations might be a little bit different, and that is okay as long as they are somewhat close. I can pick any 2 points that fall on my line, not any 2 of the red points. I want to specifically pick points that fall on my line. So for an equation of a line, we have y equals mx plus b, where m is the slope, just like we did in class, b is the y-intercept. So for my line, the y-intercept is 22 because the line is crossing through 22. Now we got to figure out what the slope is. So our change or our rise over our run. So you can pick any 2 points on the graph. I'm going to go ahead and pick 22 since that's where I started. And I'm going to go here and I can see that all of my slopes or between any 2 purple dots here, I'm going up 1 and to the right 1. Or if I wanted to pick further away, I'm going up 4 to the right 4. Either way, 1 over 1 or 4 over 4, the fraction reduces to 1 over 1. So my slope is 1 over 1x. So my final equation is y equals 1 over 1x plus 22. Again, yours might have been slightly off, just depending on how you drew your line of best fit. So using that equation, y equals 1 over 1x plus 22, we can go ahead and do part D. This is the prediction part that I was talking about. For part D, it says, use the equation to predict the baby alligator's length for next September. Now, if we look at our table, September here is month 0. So October is 1, November, December, January, February, March, April. And you can also think of it as, well, September would be 12 months after, right, to go a full year. Or you could count on May is 8, June 9, and keep going. So next September would be a month number 12 if we were to go a full year. So using my equation, it would be y is equal to 1 over 1 times 12, because 12 represents the number of month, and month is represented by x, plus 22. So that tells us 1 over 1 times 12 is 12 plus 22, that we would expect the baby alligator's length to be 34 inches. Now, if we take a look at our graph, 12 would be here. And if we go up, we can see that that line that we drew does cross at 34 inches. So we can use scatter plots, drawing lines of best fit, to make predictions about that model. All right, here you go. You got this one all on your own. I want you to try to do all 4 parts of this. Then once you've done that, go ahead, press play, and check in with the rest of the solutions. All right, so this is the line that I came up with. Again, not perfect. Ours can look a little different, and that's okay. That's part of this. So I have a couple points here at the top that are below the line. 1, 2 here that are above the line, and it looks like a couple, or 3, I guess, above the line, and a couple of them actually fall on the line. But again, with such a big scale and such precise numbers here, it's going to be a little bit off, and that's okay. So the equation I came up with was y equals negative 20 over 1, because if you look between any 2 points, I'm just going to randomly pick, I'm going down 20. The scale is by 20s, it's not 1. Down 20 and to the right 1. So that's where I'm getting that negative 20 over 1x. Plus, I said, looks like my graph crosses at 330. So my y-intercept was 330. Yours might be a little different, and that's okay. Maybe you have negative 25 over 1. Maybe you have negative 42 over 2, and then that would simplify to negative 21 over 1. So as long as it's pretty close, and it's a reasonable slope and a reasonable y-intercept, then you're okay. Now let's do D. Again, if our equations are different, our answers for D are going to be a little bit different, and that's okay. So for 3 years, years is the x value, so I am going to substitute a 3 in for the x. So y is equal to negative 20 over 1, or just negative 20, right? We don't have to write it as a fraction, times 3 plus 330. Negative 20 times 3 is negative 60. Negative 60 plus 330 would be y is equal to 270. So our prediction for 3 years is 270 bats. And if we look at our table, 3 years, that is where our line intersects 270 bats. All right, now that we've introduced the idea of a line of best fit, I'm going to have you stop here, and then we're just going to go through a bunch of examples to finish up lesson 9.2.